Okay, chapter 4, lesson 1 again, but we're doing the second part. We are still solving systems of linear equations, but today we are going to do it by substitution. So here are the notes on how to solve by substitution. Go ahead and pause and take those down in your notebook. Okay, for the first example here, we're going to start pretty easy. My first equation is a vertical line of x equals 5, and my second equation is 2x plus 3y equals 16. Since I'm having a vertical line at 5 and then another line that's crossing it, I already know that the x-coordinate is going to be 5 comma something. So I'm going to take that and substitute it into this equation. So I'm going to have 2 times 5 plus 3y equals 16. So 10 plus 3y equals 16. Subtract 10, so 3y equals 6. Divide by 3, so the y-coordinate is 2. So I know that those two lines are crossing at 5 comma 2. Now that was pretty easy because we had a vertical line, which is great because it already gives us the x-coordinate. However, some will not be that easy. On the second example, we have y equals 2x and 3y plus 2x equals 24. So I'm going to circle what y equals, and I know that y equals 2x. I'm going to substitute that into the second equation in place for the y. So the second equation will now become 3 times 2x plus 2x equals 24. So I'm doing the same thing I did up top where I circled the 5 and put it in for x. This time, y is not just a number though, it's a number with a variable. So I just put it in. When you get to this step, you should only have one variable in your equation. That's the whole point of substituting. So this equation should only have one type of variable. It should only have x's or it should only have y's. Now solve like normal. So distribute would give me 6x plus 2x equals 24. Combine like terms, 8x equals 24. Divide by 8, x is 3. So I know that these two equations are going to cross at 3 comma something. Once I have the x, or whichever variable I'm solving for, that goes back up into the thing I circled. So in order to solve for y, I'm going to do y equals 2 times, and I found out that the x was 3. And 2 times 3 is 6. So if I were to graph these two in my calculator, they would cross at 3 comma 6. On the third example, this time we have y equaling a binomial. So I'm going to circle that and put it in the y spot in the second equation. So then that would give me 2x plus, instead of y, I'm going to put 4x plus 7 equal to 4. Now again, looking here, I only have one type of variable, so I know that I did that part right. There's no distribute, so I go to combine like terms, which gives me 6x plus 7. Subtract the 7 to get negative 3. Divide by 6 to get negative half. So I know that these are going to cross at negative half comma something. In order to figure out what that something is, I take what I figured out x was and put it into the circle. So the circle is going to become y equals 4 times negative half plus 7, which gives me y equals negative 2 plus 7, which gives me y equals 5. So if I graph this equation in my calculator, those two equations would cross at negative half comma 5. The problem with the fourth example is that I need one of the variables to be by itself. So I can either solve for x or I can solve for y. It doesn't matter. I'm going to go ahead and solve for x. So I'm going to subtract y from both sides. So that would give me x equals negative y plus 5. It doesn't matter, again, which one you solve for. I could have subtracted x to both sides. You just have to have, according to our notes, the first or second equation has to have one of the variables solved for. So now I'm going to circle this and substitute it in for x. So the second equation is going to become 2 parentheses negative y plus 5 plus 4y equals negative 6. So I did it right because I'm only left with y's in the second equation. So when I distribute, it becomes negative 2y plus 10 plus 4y equals negative 6. 2y plus 10 equals negative 6. 2y equals negative 16. Y equals negative 8. Now to figure out what the x is, I'm going to take the negative 8 and I'm going to substitute it back into my original equation. So that would give me x equals negative, and then instead of y, I'm going to put negative 8 plus 5. So x equals positive 8 plus 5. So x equals 13. So if I were to graph those two equations, they would cross at 13, negative 8. Okay, for this last equation, the problem is that they have fractions, which we don't like. And so in order to get rid of the fractions, we would have to turn them all into a common denominator. Then we could cross them out. So looking at my denominators, I have 2, 3, 4, and 6. And their least common denominator would be change everything into 12. So for this first equation, I'm going to times top and bottom by 2, this one by 6, and this one also by 6. This bottom one by 4, this middle one by 2, and this last one by 3. So that all of the denominators, so 2 times 6 is 12, 2 times 6 is 12, 2 times 6 is 12, 4 times 3 is 12, 6 times 2 is 12, 4 times 3 is 12. So now all of the denominators are gone, which is great because then it gives me equations that are not fractions. So this top one would become negative 2x plus 6y equals 6. And the bottom equation would become 4x minus 2y equals negative 9. Now again, for substitution, I have to have one equation where one of the variables is by itself. I'm going to go ahead and solve this top equation for x. So first I'm going to subtract 6y to both sides and then divide everything by negative 2. Then I'll circle what the x is and sub it into the second equation in the x place. So that would give me 4 times 3y minus 3 minus 2y equals negative 9. I did it right because I only have y's in my second equation. So now I have 12y minus 12 minus 2y equals negative 9. So 10y equals 3. So y is 3/10. Put that back into the blue equation. So to find x, I'm going to do 3 times 3/10 plus or minus 3, which gives me negative 21/10. So if I were to graph these two, they're going to cross at 3/10, negative 21/10. Okay, remember this is from last lesson. So if two lines are parallel, they have no solution and they are called inconsistent equations. If the system of equations has at least one solution, we call them consistent equations. And if the system of equations is graphed on top of each other, we call them dependent equations. I'm not feeling super confident about these two equations, that they cross at 3/10, -21/10. So the good thing is that we could always check them on our graphing calculator. I'm going to go ahead and type in Desmos. So the first one is, there we go, -x/6 plus y/2 equals half. I'm just not going to read it like that. Let's see here. There we go. Okay. And then the second one is x/3 minus y/6 equals -3/4. Oh, we did it right. Good. All right.